Hello, everybody. We are going to take a look at the solutions to the college prep electric circuit homework problems 1 through 5. So let's get started with problem number 1. We have a 22 ohm resistor and a 33 ohm resistor are connected in series and placed across a 120 volt potential difference. The first part of this problem wants to know what is the equivalent resistance of the circuit. So the key thing to know here, and the key word in this problem, is the word series right there. It's a series circuit. So I know that the equivalent resistance in a series circuit is the algebraic sum of all the individual resistors. So I just have to take the individual resistors and add those resistors together. That's what we do for a series circuit. It's a different thing for parallel circuits, which we'll look at later, but for a series circuit, we just have to add up the individual resistances. So let's take a look at what we're given. We're given the first resistor at 22 ohms, the second resistor at 33 ohms, and I know that the voltage is 120 volts. I don't need that for the first part, but I'll need that information for one of the other parts of the problem. So they're looking for the equivalent resistance here. So the equivalent resistance is simply resistor 1 plus resistor 2, and that's going to be 22 ohms plus 33 ohms will give me an equivalent resistance of 55 ohms. Just a quick note on the subscripts. So we are using EQ, the subscript EQ for equivalent resistance, and then just individual subscripts here. Oops, I don't know why it's doing this. For resistors 1, 2, 3, 4. We could have as many resistors as we want. So we just have to keep track of that, especially when we start looking at the current and the voltage going across each resistor as these problems get a little bit more involved. Okay, part B. Part B is asking what is the current in the circuit. Just a quick note, if you are looking for the overall current for the entire circuit or the overall potential difference for the entire circuit, we have to use the equivalent resistance or the overall resistance of the circuit, not the resistance of the individual resistors. So we still have all of our same known values. In this case, we are looking for the current, and I know that the current is equal to the voltage divided by the resistance, and that again is just Ohm's law, and we just are using the equivalent resistance here. Let me just highlight that so we can see that. So we know that the voltage from the battery is 120 volts. I know that my equivalent resistance is 55 ohms, and that's going to give me a current of 2.2 amps. Part C. What is the voltage drop across each resistor? We still have all of our same known values from before, and in this part we are being asked to find the voltage across resistor 1 and the voltage across resistor 2. The important thing to remember is that in a series circuit, the voltage is shared across all the resistors, and in a series circuit, the current is the same across all resistors. So again, series circuit, voltage is shared, current is the same. So if I want to find the voltage across the first resistor, I have to first of all use the resistance of that individual resistor. And I need to plug that into Ohm's law. So according to Ohm's law, the voltage equals the current times the resistance. So the current of the circuit is 2.2 amps. The resistance of the first resistor is 22 ohms. So 2.2 amps times 22 ohms is going to give me 48.4 volts, or 48 volts rounded to two significant figures. And the voltage across the second resistor is going to be my current, still 2.2 amps, because the current is the same across all the resistors, times the resistance of the second resistor, 33 ohms. 2.2 amps times 33 ohms is going to give me 72.6 volts, or 73 volts rounded to two significant figures. Part D. What is the voltage drop across the two resistors together? In the previous part, we had to find the voltage drop across each of the resistors. So now they want us to know the total voltage. So to find the total voltage, we simply have to add the voltage across the first resistor plus the voltage across the second resistor. Voltage across the first resistor was 48.4 volts, and on the second resistor was 72.6 volts. That gives us a total voltage of 120 volts. Rounded to 2 sig figures gives us 120 volts, which you'll notice is the same as the total resistance of the circuit as a whole. So when we add the voltages across the individual resistors in a series circuit, we should have the total voltage of the circuit. It should come out close. It might differ by 1 volt, maybe 2 because of rounding, but it should be very, very close to the total. On to problem number 2. We have 3 resistors, 3.3 kilo ohms, 4.7 kilo ohms, and 3.9 kilo ohms, again connected in series across a 12-volt battery, and they want to know what the equivalent resistance is. So our given values are the resistances. Our first resistor is 3.3 kilo ohms, which we do need to convert to ohms, so that would be 3.3 times 10 to the third ohms. The second resistor, 4.7 kilo ohms, which is equal to 4.7 times 10 to the third ohms. Resistor 3 at 3.9 kilo ohms, which is 3.9 times 10 to the third ohms. The voltage is 12 volts, and we are looking for the equivalent resistance. Again, because this is a series circuit, to find the equivalent resistance, we just add the resistance of each of the resistors together, and we get the sum of those 3. So the sum of 3.3 times 10 to the third plus 4.7 times 10 to the third plus 3.9 times 10 to the third is going to equal, it should be 1.2 times 10 to the fourth. I think if you add those 3 coefficients together, 3.3 plus 4.7 should be 8 plus another 3.9 would give me 11.9 times 10 to the third, which I want to convert to 1.19 times 10 to the fourth, which would round to 2 significant figures, 1.2 times 10 to the fourth ohms. Part B. They are looking for the current through the resistors. So again, we're going to use Ohm's law to find the current through the resistors, but because this is a series circuit, and I know that the current remains the same through all parts of the circuit, I need to use the equivalent resistance when I'm using Ohm's law to find the current. So I know that the current is the voltage divided by the resistance, so 12 volts divided by 1.2 times 10 to the fourth ohms, remember that's the equivalent resistance, is going to give me a current of 1.0 times 10 to the minus third amps. Part C, what is the voltage drop across each resistor? Remember, in a series circuit, if I want to find the voltage across each resistor, I have to find the resistance of that individual resistor when I plug that into Ohm's law. So I'm looking for the voltage across all 3 of the resistors. For the voltage across resistor number 1, I use the current, which was 1.0 times 10 to the minus third amps, which we got from the previous part. And I use the resistance of resistor 1, which is 3.3 times 10 to the third ohms. When I do that, I get 3.3 volts. For resistor 2, the voltage across resistor 2, I should say, I use my current plus the resistance of resistor 2, 4.7 times 10 to the third ohms. And I get 4.7 volts. And for the voltage across resistor 3, I multiply the current times the resistance of resistor 3, 3.9 times 10 to the third ohms, and I get 3.9 volts. Note that if I add these 3 values up, I should get a total of 11.9 volts, which is very, very close to the total voltage of the circuit at 12 volts. And we can account for that 0.1 volt discrepancy by rounding errors and significant figures. Okay, so the final part of problem number 2, they just want you to find the total voltage drop across the 3 resistors. Again, because this is a series circuit, you simply have to add up the voltages of the individual resistors. So the total voltage is just going to be the sum of the 3 voltages that we calculated in the prior part of the problem. So across resistor 1, the voltage is 3.3 volts. Across resistor 2, the voltage is 4.7 volts. And across resistor 3, the voltage is 3.9 volts. And add those up, we should get 11.9 volts, which when we round to 2 significant figures is going to give us 12 volts. Problem number 3. 3 15-ohm resistors are connected in parallel and placed across a 30-volt battery. What is the equivalent resistance of the parallel circuit? The big thing to take away from this is that we are now working with a parallel circuit. So let's take a look and see what our known values are. We have 3 resistors. Each one of them is 15 ohms, and we have a voltage of 30 volts, which again we're going to use for the next part of the problem. But for the equivalent resistance, we just need to know what the resistance is of the individual resistors. So to find the equivalent resistance on a parallel circuit, the inverse of the equivalent resistance is equal to the sum of the inverses of the individual resistors. What does that look like? If you recall from the PowerPoint that Mr. Broderick narrated for you, the inverse of the equivalent resistance, which is that right there, it's just 1 over the equivalent resistance, is equal to the sum of the inverses of the individual resistors. And so because each resistor is 15 ohms, it's 1 over 15 plus 1 over 15 plus 1 over 15. Once you get that sum, then you need to take the inverse of that. So if we add 1 over 15 plus 1 over 15 plus 1 over 15, we will get 3 over 15. We take the inverse of that or flip it over, we get 15 over 3, which is going to give us 5 ohms. One other note I want to give you, when you're putting these into the calculator, it's good to use the inverse button, and you'll see another form of the equation. I'll show it right here, where we have the equivalent resistance is equal to, we take the inverse of each of those 3, take the sum of that in the parentheses, and outside the parentheses, we take the inverse of that as well. So now we have the inverse of the equivalent resistance is handled by that inverse sign, and we can see that the inverses of these individual resistors are accounted for, whoops, it's misbehaving here, there we go, by those inverse signs. And this one is much easier to plug into a calculator, especially if you have a TI-84 or something like that, but most calculators should have at least an inverse button on it. Part B is asking what is the current through the entire circuit. So we're looking for the overall current of the circuit. So in order to find the overall current, we have to use the equivalent resistance. Now I know according to Ohm's law, V equals IR. If I want to solve that for current, I know I will equal V divided by R, voltage divided by resistance. So our voltage of the circuit is 30 volts divided by my equivalent resistance of 5 ohms will give me a total current for the circuit of 6 amps. Part C asks, what is the current through each branch of the circuit? Because this is a parallel circuit, the current is shared across each branch of the circuit, and the voltage is going to be the same across each branch of the circuit. This is the opposite of a series circuit in which the current is the same across each part of the circuit and the voltage is shared. So in a series circuit, it's the same current but shared voltage. In a parallel circuit, it's shared current and the same voltage. So in this case, we're being asked to find the current across each one of the resistors. Now in this problem, the resistance of each of my three resistors is the same. So the current is going to be shared equally among them, which means that the current across each resistor is going to be the same. And I know from Ohm's law that the current is equal to the voltage divided by the resistance. Now, because we're looking for the current just across the resistor, we need to use the resistance of that individual resistor, not the equivalent resistance. So 30 volts divided by 15 ohms is going to give me 2 amps. And I have 2 amps going across each resistor. And there's 3 resistors, and that makes my current, my total current 6 amps, which is what we got for the previous part of the problem. Problem 4. A 120 ohm resistor, a 60 ohm resistor, and a 40 ohm resistor are connected in parallel and placed across a 120 volt battery. What is the equivalent resistance of the parallel circuit? So we have our known values, our 3 resistances, and our voltage across the battery, which is 12 volts. Just as a quick note, when the problem says voltage across the battery, you can interpret that as the voltage of the entire circuit. So in this case, we are dealing with a parallel circuit. So when we are dealing with a parallel circuit, we want to find the equivalent resistance. We know that the inverse of the equivalent resistance is going to be the sum of the inverses of the individual resistors. So when I put that into my problem, I'm going to have 1 over 120 ohms plus 1 over 60 ohms plus 1 over 40 ohms is going to be equal to 1 over the equivalent resistance. Now, there's a couple of ways, again, you could do this problem as I explained in the last problem. You could use this as a fraction, and I know we're just adding one more thing for you to love about physics, because what's the one thing you love about math that you haven't really been doing a lot of yet? Adding fractions, and y'all love fractions. I do know that. So I could do this by finding the lowest common denominator or the least common denominator for all of these values. For this one, it wouldn't be particularly difficult because that would be 120 ohms. I can promise you, you're going to have a lot of problems moving forward where finding the least common denominator is not going to be that easy. So I would recommend doing it the second way that I'm going to show you in just a moment. But if I did that, if I did it like this and I wanted to add up all these, I would end up with, let's see, 1 over 120. And why am I doing that in highlighter? Let me switch to pen here. 1 over, I'm going to do this again, 1 over 120 plus, that would be 2 over 120 plus 3 over 120 will give me 6 over 120. And remember, I need to take the inverse of that because of that. So that's going to give me 120 over 6, which is going to give me 20 ohms. If we use the other form of the equation that I showed you before, it's much easier to do, especially if you're punching it into the calculator. What you would want to do is enter it into the calculator so it looks exactly like this, and you'll have the inverse of 120 plus the inverse of 60 plus the inverse of 40, and we take the inverse of the sum of those three, and that will give me my equivalent resistance. And either way, you'll get 20 ohms. Part B asks, what is the current through the entire circuit? So because we're looking for the current through the entire circuit, we're going to need to use the equivalent resistance when we plug it into Ohm's law. And I know that according to Ohm's law, the current is going to equal the voltage divided by the resistance. And you'll note here we use the subscript T. That subscript just signifies that we're looking for the total current for the entire circuit. So the voltage is 12 volts and my equivalent resistance is 20 ohms. 12 divided by 20 is going to give me 0.600 amps. Part C asks, what is the current through each branch of the circuit? Now, because this is a parallel circuit, I know that the current is going to be shared across each branch of the circuit. So if I am looking for the current across each branch, I just need to do them individually with the resistance of that particular resistor. Now, unlike the previous problem, each of the three resistors has a different resistance. So the current is not going to be shared equally. So I have to calculate each one separately. So for the current through the first resistor, I use the voltage, which is 12 volts, divided by the resistance of the first resistor, 120 ohms. 12 divided by 120 is going to give me 0.100 amps. For the second resistor, I should say the current through the second resistor, I know that the voltage is still 12 volts because remember, in a parallel circuit, the voltage is going to be the same across each branch of the circuit. So just like for resistor 1, we had 12 volts. For resistor 2, we have 12 volts, and we'll have 12 volts for resistor 3. So for the current through resistor 2, it's going to be 12 volts divided by the resistance through resistor 2, which is going to be 60 ohms. And 12 divided by 60 is going to give me 0.200 amps. And for resistor 3, the current going through that is going to be the voltage, 12 volts, divided by the resistance of resistor 3, which is 40 ohms. And that is going to give me a current of 0.300 amps. And if I add the current going through each of those three resistances, 0.1 plus 0.2 plus 0.3, I'm going to get 0.6 amps, which is equal to the total current going for the entire circuit. Problem 5. A 150 ohm branch in a circuit must be reduced to 93 ohms. A resistor will be added to this branch of the circuit to make this change. What value of resistance should be used, and how must the resistor be connected? So this problem is asking two things. First of all, we need to add a resistor into this circuit to bring the resistance from 150 ohms down to 93. And how should we connect it, in series or parallel? Well, my resistance of the first resistor is 150 ohms. My equivalent resistance is 93 ohms, and I'm looking for the resistance of a second resistor that I can add to the circuit. Because my equivalent resistance is less than the resistance of the first resistor, I know that I'm going to have to add this second resistor in parallel. Because if I add it in series, then I add the two resistances of the two resistors together, it's going to be greater than, my equivalent resistance will be greater than the first resistor. So in order to get the equivalent resistance to be less than the first resistor, I have to add my second resistor in parallel. So in order to do that, going back to my formula for equivalent resistance for parallel circuits, I know that 1 over the equivalent resistance is equal to 1 over the resistance of resistor 1 plus 1 over the resistance of resistor 2. If I solve this for resistor 2, I know that 1 over the resistance of resistor 2 is going to equal 1 over the equivalent resistance minus 1 over the resistance of resistor 1. I've just subtracted the resistance of resistor 1. Oops, let me get the pen ready. The resistance of resistor 1 from both sides. So I just subtracted that from both sides of my equation, and then I ended up with this. So 1 over 93 ohms minus 1 over 150 ohms, and I take the inverse of that, is going to give me 240 ohms, and I know I need to wire it in parallel. The alternative form of the equation would look like this, and you would want to punch it into the calculator just like that, and you will still get 240 ohms. Okay, guys, that does it for problems 1 through 5. How many times have I used the word resistance or resistor in this video? If you get really bored in your social isolation, you can count them up. I bet it's a lot. Take care, and I'll see you for problems 6 through 10.